Okay, so this is going to be the worked out answer key for your homework assignment worksheet 7-3 on triangle similarity. So I'm going to go through the problems. Hopefully you've tried them already and you can just refer to this as you need to for the ones you had trouble with. Explain why triangles are similar and write a similarity statement. So if I look at this, I'm going to go through my reasons. What reasons do I have to show triangles are similar? Well, I know that if I can show two angles are um, congruent in the pair of triangles, that's one reason. I know that I can show side angle side similarity, and we know that we can also show um, similarity by showing side side side. So these are all ways to show triangles are similar. So here, if I look, I can see that I have an angle. So I'm going to suspect that it's going to be side angle side um, or angle angle. Yeah, so I spoke kind of quickly about side angle side. I don't know the sides. So it's probably going to be angle angle. And in fact, it is because I know that here we have um, two angles, right? And then I have this 90-degree angle. So I'm guessing that I should be able to show that these triangles are similar. Now I notice right away that this is 43 and 47, so that might be a problem because they're different. And my 90-degree angles, I know that's congruent, but I know that I can find this third angle as well, right? So all the angles add up to 180 degrees. I know in a 90-degree triangle that I can subtract from 90. So 90 minus 43, and hopefully I'll get 47 here. So there'll be 10, 7, and this will be 8 and 4, not 5. 4. And so I did. And so based on that, I know that this angle is 47 degrees. And this angle has to be 43 degrees. So so why are they similar? They're similar because I know that all three angles are congruent, or I could use the fact that I have two angles that are congruent to two others. So let's just use one of our postulates here. So I'm going to say they're similar by angle angle. And what's the angle angle that I'm going to say? Well, we have a 90-degree angle, a 90-degree angle, and we have this. It's your choice. I'm going to use the 47 and the 47. So let's write my similarity statement. I'm going to say um, triangle. I'm going to start with the green angle that I marked. So triangle CBA. So I went green, yellow, and then the one I didn't mark is similar to triangle, and I'm going to go the same order. So green. So I'm going to say F, then yellow FED. You could have named them differently. Um, by angle angle similarity. So this is my reason. So again, it asks us to verify that these triangles are similar. So let's see. Why might they be similar? Well, I notice that this has vertical angles, and um, I know the I know and those vertical angles are included in the sides values that I know. So I know this side, I know the vertical angles are congruent, and I know this other side. So I'm suspecting that we should be able to use side angle side similarity to show these are the same. So as I look at these triangles, it appears to me that this, if just looking at this, it looks like this angle is going to be matching this one, and this angle is going to be matching this one. Now you can't always assume, but we're going to start with that and see if our sides match up in that way. So if I were matching in that particular way, then then this U is going to match this UX is going to match WX, and and again I'm just making a guess here. Then the TX is going to match VX. So we're going to know when I do the actual ratio. So let's do the blue ratio first. So I'm going to go from the small to the large. So um, I'm going to say 12 over 16, and I'm questioning whether that is going to be the same and as the 15 over 20. And so let's see. So I'm going to reduce those. 4 goes into 12 3 times. 4 goes into 16 4 times. So I get a fraction of 3/4 for the blue ratio. And for the red ratio, 3 goes into, or 5 goes into 15 3 times, and 5 goes into 20 4 times. So I also get 3/4. And so this is true. They're equal to each other. And so I have the two sides are in proportion. So I can say that the ratio of, let's use the right color. So I know that I've shown that Tx over Vx is equal to Ux over Wx, and that's all equal to 3/4. So the sides are in proportion, and then the last thing that I'm going to say is that angle TXU is congruent to angle VXW by vertical angles. And so the triangles are similar, so we're going to say triangle TXU is similar to triangle VXW by side angle side similarity. So we're going to explain first of all why these two triangles have to be similar, and then once they're similar we can use that information to find the length RT. So the first, let's identify the two triangles. So we have the small triangle RSV, and then we have the larger triangle RTU. And why do they have to be similar? Well, here's the reasons. We know that we have some information on sides, but we don't have enough information to use side, side, side. So what we want to use is angle, angle, because we don't have enough side information. So if we can show that two angles are two pairs of angles are congruent, then we'll know they're similar. And so why are there two pairs of angles congruent? So the first thing to notice is that we have this transversal RT, and it crosses the lines SV and TU. That means that these are corresponding angles at S and T. So if these are congruent like they are, that means that this SV and UT view are parallel lines. Well, if these are parallel lines, then these other angles on the other side of that triangle, at the angle at RVS and RUT, they are also corresponding angles. So based on the fact that these lines have to be parallel, because of the converse of the parallel or corresponding angles postulate, then this angle here at RVS and RUT are also corresponding angles, and because the lines are parallel, they are congruent. And so now we have two pairs of parallel lines. Or two pairs rather of congruent angles. So we know angle RSV is congruent to angle RTU. How do we know that? That was given. And so then we have angle RVS is congruent to angle RUT. What is the reason for that? Well, it's the corresponding angles theorem and its converse. So we use the converse first to show the lines are parallel, and then we're going to reason that because they're parallel, then the other corresponding angles are congruent. So the converse of corresponding angles postulate and the corresponding angles postulate. We use both of them. All right, and so now we can say the triangle RSV is similar to triangle RTU. And that's by angle-angle similarity. All right, so we've shown the triangles are similar. Now that they're similar, we can use that to find that length RT. So RT is this whole length of the side of the triangle. Well, we know that the ratio, the proportion of the smaller to the larger triangle is going to be 8 over 12 based on the sides SV and TU. So when I use the smaller side of the larger triangle, I mean the smaller side, the other corresponding sides here, the smaller side 10, it's going to match RT. So I'm going to be able to say, well, 10, 8 is to 12 as 10 is to whatever length RT is, which is what I want to find out. And so then I can solve this proportion. So I have 8 times whatever RT is, that length, is going to be 120. And I divide by 8, divide by 8. So the length that I'm interested in, RT, is going to be whatever 120 divided by 8 is. So 8 goes into 12 once, and there's 4 left over, so 4 zeros, 48 into 40 is 5. So RT is going to be 15. And so that's our answer. Okay, so this picture is a little more complicated than what we've been looking at, but we have a lot of information, and it's not a hard problem, given that we know something about these triangles. And we're trying to show that that larger triangle, this triangle JKL, is similar to the smaller triangle that's formed from the midpoints of each of the sides of the larger triangle. Well, remember, we have that information that we proved earlier in the year, that this mid-segment theorem, so you might have to think back a little bit. What did the mid-segment theorem tell us? It told us that if we formed a triangle by the midpoints of the sides of another triangle, that each side of this little triangle inside, triangle NPM, would be half the length of the matching side. So we know that, just for example, if I look at this picture, I'm going to use the blue highlighter, that this side MP is going to be half the length of LN. And so we're going to, or sorry, I said LN, half the length of LK. And so we're going to, we're going to use that fact to show that these triangles are in fact similar, using side, side, side. And if you have trouble looking at the picture and matching them up in the correct order, you can see here that if I'm talking about MP, then it's going to be LK. So MP, LK, right? So let's write this up. So I know by the mid-segment theorem, which we proved earlier this year, so we can use that. So we're going to say that MP over the ratio of MP to LK is going to be equal to, and so let's do the other side. So again, I did MP, so let's do PN to KJ. So PN to KJ. And then I'm going to go, so I did MP, PN, now I'm going to go NM and JL. So NM and JL. We know by the mid-segment theorem that's equal to 1/2. The smaller lengths are half the larger. And that's by the mid-segment theorem. Well, given that, we've shown exactly what we need to show. So now I can say triangle JKL is similar to triangle NPM by side, side, side similarity.